The MCAT Podcast, session number 151. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT Podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help get you the score you deserve so you can one day call yourself a physician. Welcome to the MCAT Podcast. My name is Dr. Ryan Gray, your host here every week, where I get to have a great discussion with Clara from Next Step Test Prep. If you are looking for some help with your MCAT prep, look no further than Next Step Test Prep. They have the best MCAT course out there, the best value of an MCAT course out there, that you can find a great review at mcatcoursereview.com. Again, mcatcoursereview.com to check out the MCAT course from Next Step Test Prep. Today, Clara and I are diving into the best subject for the MCAT, amino acids. Clara, back for some more MCAT podcast. Last week, we covered what is high yield, and we went in depth on kind of what students should be thinking about, what they should avoid with high yield topics. And now I'm excited to jump into some individual topics in high yield. This week, starting with biochemistry and amino acids. Now, I would hope that 80+% of students know, because they've heard, that amino acids are just something you have to know for the MCAT, inside and out. Why are amino acids so important?
Well, so amino acids are huge on the MCAT. And the really funny thing is that they weren't actually tested at all on the MCAT prior to 2015. So it's this kind of remarkable thing where the MCAT went from not even asking about amino acids even in the slightest to amino acids being like the biggest MCAT topic that exists right now. And I think a big part of it is just their so first of all, of course, their biological relevance. Like amino acids are relevant to diseases as well as their like fundamental role as the monomers in proteins. But then also the way that amino acids let the MCAT test makers ask questions about almost anything. Like they're relevant to biology. Like, so I've seen amino acid questions that look like biology questions. I've seen them that look like straight up general chemistry questions, which we'll see some of those today. I've seen organic chem ones about like the carboxylic acid groups. Like they're just this amazing topic where you could almost ask about like everything on the MCAT in relation to amino acids.
Yeah, it's hard because I'm on this side of it. I'm like, I don't remember using amino acids at all in med school. And obviously once you're practicing, it's like, oh, that's not important. So it's hard. I think I used more amino acids as a personal trainer talking about nutrition and let's make sure we're getting our amino acids to build those muscles. So it's a struggle to understand why they're so important. But I can't fight it. The AAMC says it's important. The MCAT test writers test it, and so we need to be prepared for it. So we have some questions today that will cover some amino acid topics. If you want to follow along in our handouts, go to the mcatpodcast.com/151 for our episode today. All right. Why don't you go ahead and start with question 1?
Sure. Question 1. An unknown amino acid is titrated with 1 molar NaOH according to the following titration curve. And here I actually included a titration curve. And so if you don't have the handout, I can just describe what it looks like. So we see this titration curve here with 3 points on it that are labeled. There are 3 points along the flat parts of the titration curve. And they're labeled 2.18, 8.95, and 10.53. So otherwise, totally standard titration curve, but we need to figure out what those mean. Okay. So then the question is, based on the given curve, the unknown amino acid is most likely A, serine, B, AS. Oh, they give the abbreviations here. So A, SER, B, ASP, C, LYS, or D, ALA.
Yeah. So this is one of those fun, board questions, like first removed or second removed, whatever it is. Because first of all, you have to know what those abbreviations mean. You're like, shoot, I forgot to study the abbreviations. but hopefully those
Mhm.
are easy enough. And so I'll go ahead and let you dive into each of these and how we figure that out, because obviously there's no way I'm going to know this.
Totally. So there are so many steps to amino acid questions. So just like you said, the first step is just knowing what the abbreviations mean. So I gave that one away, but that's an easy one. That's serine, because it's the only amino acid that starts with anything close to SER. B is harder actually because its abbreviation is ASP, and that is aspartic acid or aspartate. There's actually another amino acid, asparagine, that starts with ASP, but that abbreviation is ASN, not ASP. And then C is lysine, and then D is alanine. So those just start with their first three letters. So that's the first step. And if you can't get past that step, you are in big trouble with questions like this. But even once you do get past that step, you have a lot more to do. So the next step, now that we know what amino acids are even options, is to look at the titration curve. And the biggest thing we see is that there are three numbers listed on it. And even if we don't remember that much about titrations, we should know that that means there are three equivalence points. So here they've actually labeled the half equivalence points, which are the flat parts of the titration curve. But we can think of it similarly as, oh, there are three equivalence points. And that means that our amino acid has three acidic or basic groups. And so amino acids always have either two or three. So something like serine or even alanine, so A and D here, actually only have two because their side chains are not acidic or basic. So serine and alanine, they have two groups that can become protonated or deprotonated, but they only have two. So they don't have a third one. So there wouldn't even be three numbers on a titration curve for those two options. So those are out. And then we're down between B and C. So B, aspartic acid, or C, lysine. And aspartic acid is acidic, so its side chain does have a half equivalence point. And lysine is basic, so its side chain has one as well. So now we actually have to look at the numbers themselves to tell which is the right answer. And we can see that, okay, our first point, 2.18, that's a really standard pKa for a carboxylic acid. So like every single amino acid you see on the MCAT is going to have 2 point something as one of these numbers, one of these pKa's. So that doesn't help us. And the second one, 8.95, well, that's a really standard pKa for an amino group, which every amino acid also has. So that also doesn't help us. But then this third one here, 10.53, that's a really high pKa. And when you see high pKa's with amino acids, you should think basic, just like you would think high pH is basic. And so we're looking for a basic amino acid here, and our answer is C, lysine.
See, I would have gotten that right because it's like, I don't know anything, see and move on. Love that skill.
That works. Sometimes.
That is always the skill that I use. Okay, so interesting. So those are definitely, I think within that, right, obviously amino acids being high yield itself, I think those are some good high yield things that students should be aware of for each of the amino acids. And I know we've covered it probably more than a few times, but let's run down real quick the things that students need to know about amino acids, right? Knowing I think there are single letter, the three letter, the acidic or basic, the side chains like 2 or 3 or however many there are. So run down those kind of high yield per amino acid that students should just know off the top of their head and be able to write down. If I said, okay, pull out a sheet of paper and write down all the amino acids with all of this information.
Oh, totally. So basically there's kind of like this hierarchy of things you should know about all the amino acids. And by hierarchy, I just mean in order of importance. So by far, the most important thing to know about every amino acid is the abbreviation. So there's a 1-letter abbreviation and a 3-letter abbreviation for every one of them. The 1 letter tends to be harder, so you should definitely focus on that. And they also tend to use it really frequently. So sometimes on the MK, you'll see this long strand of letters, and they'll just look like random letters, and they'll be amino acids. So you need to know what those letters stand for. And then beyond the 1 and 3 letter abbreviations, the next thing you absolutely need to know is the status basically of each side chain. So amino acids all have the same backbone structure. Their side chains are what is different. So that is when you see like, this amino acid is acidic, or this amino acid is nonpolar, or this one is like polar uncharged. That is all in relation to the side chains. So you need to know every one of the 20 amino acids, what word essentially describes its side chain. Is it polar? Is it nonpolar, etc.? And then that's really the core of it. So beyond that, you can get way in depth with like questions like this sort of combined a ton of information, little pieces of information we needed to know. But beyond that, basically, I would say the next important thing to understand is just how those side chains interact with acid-base chemistry. So something like here, for example, the fact that we saw 3 pKa's means it's a basic or acidic amino acid. So that's the next sort of conceptual level you should go up. And then I always just like to end with a sort of caveat, that is to say, a lot of biochemistry classes will tell people to memorize the exact structures of all the amino acids. Like, once you know all of this information, like you need to go like one level higher and be able to draw them all. You do not need that for the MCAT. So if you want to try drawing out all the amino acids and you think it'll help with your confidence or something like that, that's totally fine. But you will never be asked to like draw histidine, for example. You just need to know abbreviations. Is it acidic? Is it basic? And what does that mean for general chemistry, essentially?
Okay. So there's some lots of good stuff to know. All right.
Lots.
All right. So I'll go in here to question 4. So the alpha helix is a common form of secondary structure in proteins. It is a compact, right-handed helical structure that is stabilized by tight packing, as well as hydrogen bonding between backbone C and O. How do you say that together?
C double bonded to O, I would just say.
Yeah. It looks like C equals O, but yes, that's a double bond. So C double bonded to O, or carbon to oxygen, and amino groups. Based on this information, the incorporation of which amino acid would most disrupt the alpha helix? A, alanine, B, aspartic acid, C, cysteine, or D, proline? Oh, all right. So it defines alpha helix, a common form of secondary structure in proteins. It's compact, right-handed helical structure, stabilized by tight packing, as well as that hydrogen bonding, the double bonded carbon to oxygen in amino groups. So we want to know what's going to disrupt that bonding. I'm assuming is basically the question. What's going to disrupt the bond, or maybe disrupt that right-handed helical structure? Which is obviously there because of the bond, maybe. And so, yeah, I'll let you take it from here because, again, these ones are going to need so much more information than I have.
Yeah, that's cool. You just guess C.
C and move on. There you go.
C and move on. C is wrong with this one. So.
Oh, thanks. Thanks for setting me up.
Yeah, it doesn't always work, but... so this one actually looks kind of long and convoluted, but it's actually, I wanted to include it as an example of a question that's way, way, way simpler than the first one we did, as long as you have the right information. So this is where we actually go beyond all of the stuff we talked about that you need to know about amino acids, and we get into these weird little special characteristics of a handful of amino acids. So in this case, what they told us in the question stem is, okay, this is what an alpha helix is. You might already know what that is because it's kind of just MCAT knowledge that you should have. So it's basically just saying, if we summarize it, which amino acid disrupts alpha helices? So which amino acid disrupts the hydrogen bonding that makes an alpha helix? And the answer to this is proline. And this is just a fact that you should absolutely memorize. Like, proline has a really interesting structure where its amino group is actually attached to its side chain. So you'll see this funny looking ring structure if you look up what proline looks like. And because of that, it is basically bent in a way that a regular amino acid isn't. And we always say that it introduces kinks in alpha helices. And so basically, proline is just the amino acid that disrupts alpha helices. That's just what you should know. And the others all aren't proline, so they're wrong. And there are a handful of other facts you should know about individual amino acids, but this is the only one you need here.
So this one sounds like the like description or the reasoning for the answer is C is wrong because it's wrong, and B is wrong because it's wrong. Just like I know there's some AAMC memes out there we talked about that's like the answer is wrong because it is.
Yeah, and sometimes that really is the explanation. Like ideally, that's not the explanation for every question, but for this one, yeah, it's not proline.
So it sounds like again, kind of going back to individual high yield for each amino acid. It sounds like maybe there are some of these special features of each amino acid that students should be aware of. Like here, proline disrupts alpha helices.
Yeah, totally. So proline disrupts alpha helices. That's it. There are others too, like methionine and cysteine have sulfur in them. There are all these little simple facts. And if you have any set of MCAT books, they'll get into them. But yeah, it can just be easy points if you just happen to know that one fact.
I like easy points. I will take them all day. Exactly. All right. Question number 6 here.
All right. This is a Roman numeral question. So
my favorite.
Yeah. Which of these statements describes the amino acid W at physiological pH? Roman numeral 1, it has no net electrical charge. 2, it is not a zwitterion. Or 3, it is neither acidic nor basic. And then our answers are all combinations of those. So A is 2 only, B is 3 only, C is 1 and 3 only, and D is 1, 2, and 3.
Yeah. And so step 1, what is the amino acid W? And because I have quick Googling skills, I found out that it is tryptophan, which you get to that, like, how do you get W out of tryptophan? Huh.
Tryptophan is like the weirdest one with abbreviations. There's actually a trick for it, by the way. We always say tryptophan, if you ever look at its structure, it will really stand out as having like these 2 rings that are like right next to each other. And we always say, oh, like W looks like 2 V's that are right next to each other. Tryptophan has these 2 rings that are right next to each other. But it's about as close as you can get with a weird letter like that.
All right. It reminds me of, there was some comedian, and I forget where it was, if it was in a movie or TV show or something, but there was a comedian that talked about the people who brought us like the 2-letter state abbreviations. Like the same people that brought us o'clock, right? Saving us of the clock. It's o'clock and all these weird kind of abbreviations. And he starts down the list starting at like Alabama or wherever. And he's like, oh, this is going to be easy. And then he gets like to the next state. He's like, crap, we already used that one. And just going down this list, and it's hilarious. So that's what this reminds me of. But all right. So tryptophan, another fun little tidbit there of 2 circles next to each other, like 2 V's. So W. And then again, kind of just knowing, you have to know the electrical charges of each of these amino acids. So that would give you whether Roman numeral 1 is true or not. And then again, knowing if the amino acid is acidic or basic would give you number 3. And then you're kind of left with, I have no idea. I forget what a zwitterion is, but if I know 1 and 3, then you should hopefully get to your answer. So I'll let you kind of break that down.
Totally. Yeah, this one, again, looks kind of complicated, but really, as long as we know what tryptophan side chain is like, and of course, as long as we know we're talking about tryptophan, then we'll be in pretty good shape. So basically, just to give it away, tryptophan is an amino acid that has a side chain that cannot become charged. So it's not an acidic amino acid, it's not a basic amino acid. The side chain doesn't become protonated or deprotonated. And because of that, we can actually get rid of some of these answers or pick some of them. So as soon as we know that its side chain doesn't become protonated or deprotonated, we know that 3 is right because that's just saying, oh, it's neither acidic nor basic. So that's perfect. And then, okay, so 3 is part of our answer. So that gets rid of A. And then as long as we know for all of the amino acids that have side chains that we essentially just like don't have to worry about, so side chains that don't become charged, for all of those amino acids, they're all zwitterions at physiological pH. And what a zwitterion is it's just a structure, like a species or a molecule essentially, that has equal numbers of positive and negative charges. So you always hear it described as like this molecule that is charged but is still neutral overall, because maybe it has like one positive and one negative charge. They add up to 0. So tryptophan is one of those at physiological pH. So 2 is out because it is a zwitterion, so we can get rid of it is not a zwitterion.
That one for me, I'm like, oh yeah, it must be 2 because it has zwitterion. I'm like, oh, it is not. Darn it.
Be careful. Yeah, it's easy to miss here. Usually they'll capitalize not if it's a not question, but if the word not is in a Roman numeral, it doesn't abide by those rules.
Yeah.
So,
okay.
So 2 is out, and we know 3 is in. And then 1, no net electrical charge. Well, it is a zwitterion, and that's true of all zwitterions. They always have no net charge. So 1 is correct, and our answer is C, 1 and 3.
See, I would have gotten it right. Pick C and move on.
Not a bad strategy.
All right, so there you have it. Amino acid discussion and high yields. But don't fret. There's more amino acids on the way, even though next week's discussion isn't really about amino acids. But of course, they infiltrate every part of the MCAT. I hope you got a ton of great information out of the episode today. Don't forget to share this episode. I would love for you to take a screenshot of you listening to this podcast right now, share it in your Instagram story, tag myself at Medical School HQ, tag Next Step Test Prep at Next Step MCAT, and let us know and let your friends know that this podcast is out there for them for free MCAT prep. Hope you have a great week. We'll see you next time here on the MCAT podcast.
This is MedEd Media.